right? Right, but I'm kind of want to do it individually, yeah, like you might have to something else. Right, so we can see how we can get it done.
So but then so in that like one to one
I run to it. So until once, and that's why I want to focus on that's why I want to focus on where I get in trouble. Okay, so we're taking a look at diffraction grating type question, right? So tell me what you think about this one here. Right, again, these are the only two relationships that we use in today, right?
so you know what I would advise you go to the but
What proof?
yeah,
This one really have a proof for it, kind of. Okay. Huh? I don't know. They can't look your mark, but I never come. Right? Look at this one. Where I think this one is here. When you were it once right all the go. About 9 times. Right? Take a look at it. What do you think? It's a diffraction grating, right? See we can find theta. See we can find theta. So if it's a diffraction grating, you have to figure out what is A, what is N, and what is lambda, right?
Isn't that No, I just feel like the night. I remember from class on Friday. What? So what did that is very remember that you know, yeah. That's much like you know, this is not really and what like I told you. 600 of the last one. The last one, yeah, but before, you know, that so it was that last one. So it was yeah, but 600, 691 there. Yeah. And 1 meter is that's almost significant. Right? That's not it. That's not so. then like what second.
All right.
And this, yeah, so.
All right. So let me see how we doing this, right? What people join? Oh. All right. So at what angle does this second order? That means n is 2. Constructive interference of 2 for red light. They give you the wavelength and they give you the number of lines per millimeter. So what do we have to do to find A?
So the thing yeah, and multiply that with 1 over 600 that.
Now you have to be careful. Close it. So 600 lines is equal to 1 millimeter.
Okay, but I told you I don't know. I didn't know.
Right? So what you have to do is it does 1 millimeter, you multiply by 1,000. Right? Lines in 1 meter. So you can put the millimeters to meter, and then you find for one line, which is 1 over 600,000, which is the value for E. That's okay? Now that we get the value for E, we can work out E sine theta is equal to n lambda. Okay? We want to find theta. So theta is sine inverse n lambda over E.
Yeah, it's 700
Yeah, meter.
meters.
So that'll be sine inverse 2 by 700 by 10 to the minus 9 over E, which is 1 over 600,000. And you got what? 57. Yeah.
7.1.
Okay. So you gotta understand the principles here then.
Yeah.
Right? Okay. Right. Right. So here, since you all kind of catch up before I go on to the next part, right? I want to just show you something. Right. While you're all thinking, right? So what you would recognize, right? What you would recognize, right, is that theta is what? Theta is the angle between the 0 order and any of the orders, right? Any of the orders, any of the where the orders occur, right? What's the biggest value theta could be? Look at the diagram on the board. What's the biggest value theta could be? What's the biggest value theta could be? So imagine theta on a screen.
Can it be a dot?
90. Because when theta is, if the screen is here, when theta is 90, that ray not going on the screen anymore.
Yeah.
So the biggest value that theta could be, right? Ignore this. Okay. Right? The biggest value theta could be is 90. Right? So therefore, the maximum value for n occurs when theta is 90 degrees. So if you look at this formula here, if you look at the formula, E sine theta is equal to n lambda. Is it possible to come up with a formula to find maximum orders?
It's like
Right? So it will be E. Okay, it will be E sine theta on lambda n. But theta is what? Theta is 90. So if I put E,
and then having 1.
If I put A sine 90 over lambda, sine 90 is what? 1. Right? So technically it's A over lambda. Alright? A over lambda. Well, it doesn't stand up outside, you know. Right? A over lambda. That's okay? So, do me a favor now. Let's go back to the same question. Copy that down. And let's go back to the same question and see if we can find the maximum number order. Okay?
0.3.
Right. Divided. I'm going to take care of some.
That's what what's so you get the ball right to that bit. Here, then it's like that. What like that's a good.
Right. So for this one here, right? Right. So if I just go back to this last one here, was A again, A was 1 over 600,000 and lambda was 700 something. 700 by 10 to the minus 9. And when you work it out, you got what? Right. So what do? Round it down or round it up? Oh, you round it down, right? Because 3 not possible. Right? Even if you get 2.999999, that's a max. 2.999. That's not possible. That order is only whole numbers. Okay? So therefore, you always round down. Okay? So even if you get 2 point, right? Even if you get 2.9999, it don't matter. 3 is not possible. So the maximum number of orders is 2 because orders integers. Are you okay with that? Orders integers. Yeah. Right. So just make a note that we always round down, right? bypass money. Not because my back I tell you. Oh. Yeah, we start. Anyway, do this fast. Next one. One. So we just trying to master this concept, right? Well, again, you can feel like what again trying to do. No.
So all like everything is a template. Yeah.
Oh yeah. Do this one fast.
you have to see who's your percentage. Yeah. But they say yeah, how do you be like that? Oh, you get you like so you just do it. I did that. They say it's right. It's a bit
So everybody is one people. That's the result. Hold on, I ask question. What's the example? Let me just talk about school and.
Oh my gosh, yeah. I best was something here.
Alright, we'll see. Alright, there you go. No. Remember, is how big one line is. 1 over 10 meters here. Also, I do that here. What is 10 meters? Okay. Remember, let's explain what I'm saying, right? A diffraction grating, no, you know. A diffraction grating is this shape. Right? A diffraction grating, that is a glass, right? The piece of glass with a hole to the cutting on it. Every one of those cuttings is an opening. That's E. Right? So if you have 600,000 cuttings here, you're trying to find the width of one of them in meters. Okay? Yeah, so we had to work backwards and see what happens. I'm gonna do it now. You're looking to see, so if they give you an angle, would E change? No. Would lambda change?
Yes.
Again, fine by N.
No.
So you're trying to see, so you're trying to find which order would I think you will there. Prefer you should talk to people nicer than that. You come to podcast, you can't talk to people.
When is this?
Let's have 2 chairs there. We just try it. I don't know how to look.
Yeah.
Right? We just talk and we just see where it end up. We just see where it end up. It's about a minute or 2. It's sorry. Are you ready? That I think pointed it. Oh, the facial reaction. Then I don't see all my own unit to do a second place already.
When you see it, I saw it. I just
Which camera?
Which camera?
One now install one.
Yeah, he knows it.
Not live.
Oh, good right. Hey,
This one alive it. This one's an AI camera. So this one will be able to watch and predict your movements. No, black one has to do that.
Yeah.
Not the white. Alright, so let's see. Alright, so let's see. I want to explain this one and it's on the board, right? I'm just writing down the values that we have. Soraya and Keelan, I'll just send some values up. So it's 4.55 by 10 to the 5 lines per meter, right? They said that for violet light, order is equal to 1, that's for violet. Order is equal to 1 and theta is 11.8. And for red light, the first order, theta is equal to 15.8. They want you to find the wavelength and what happens. So they want to get the wavelength of red, the wavelength of violet, and then they want to know what happens. All right, nice. Not looking wrong, but it should be nanometers, right, Kaden? And part 2 is they want to know what happens at 54.8, right? So I just logging out there. Right, so what you see? First thing first, right? We want to get E. So here we have 4.55 by 10 to the 5 lines in 1 meter. Okay, we want to find for one line because this already in meters, right? So that'll be 1 over 4.55 by 10 to the 5. Okay, you can leave it like that. That value is E. Okay, you can leave it like this so you don't have to round it up when you work it out. All right, and then you want to get lambda. So we're using A sine theta. We're using this because we're dealing with the fraction grating. A sine theta and lambda. Lambda is equal to A sine theta all over n. So let's do it for violet first. Sorry, for violet first. That will be E is 1 over same diffraction grating, right? 1.45 by 10 to the 5. Right? By sine theta. Theta is 11.8 all over n. N is 1. So for violet, what you all got? 4.94 by 10 to the -7, which is 494.
Say 4.494. Yes.
4.49 nanometers. Hey, all the placement goes.
So it was easy.
Right? And what's the wavelength for red? What's the wavelength for red? That's why you get on in class and put it in school.
Yeah.
Oh.
5.9.
4.55 by 10 to the 5 sine. Huh? I just got it in school. 15.8. He's a simple one. You have some potential. What I got here?
5.98 by 10 to the -7.
5.98 by 10 to the -7, which is 598 nanometers. No, you don't have to. I just put it in there because most of the time you see wavelength. That's what it will be in. Right? And when you do the colors, these are the colors. Right? You have to learn this earlier. There are questions, but they tell you it's red, and you have to know what the wavelength of red is. Right? Just like red, yellow, blue. Right? But that's thing you can figure out. But red, remember Roy Chiben? Right? So you have no red, yellow, and blue. Right? Once you know those three, you can kind of estimate the others. Right here. Part 2 now, they want to know what is happening here. As I said, A and lambda will not change.
So, question, right?
Yeah.
So, if you do, so, if you can have, let's say, you have n equal to 9, right?
Yeah.
That's the maximum.
Yeah.
Right? Then would if you get n when you put in that equal to 3.9999, you round up
Same. Well, what you say wouldn't really make sense, right? But
What? Oh.
what I mean, like, if I get the max as 9, but you're working out the n here,
Yeah.
yeah, 6 still round up. Still kind of round up. But I see what you're saying here. Right? So when you work it out for violet, what you got? 3.999. And when you work it out for red, what you got? 3.0. Right? So basically, at this angle, they are in the same order.
You know, so
therefore, well, it won't be red, it won't be white, it'll be close actually. Right? It'll be a overlap between red and violet, which will be very close, but remember, all this missing. So when if you have all, then you'll get white. Right? So at this angle here, there'll be an overlap. No. If all the colors overlap, you'll get white. White. Remember, all these colors here make up white. That's okay?
Yes, no. If it makes sense.
Right? Next one. All right, last one, right? And then we take a look at last one. You'll see now. Just the calculations, right? Just the calculations alone. So I already explained that. Or in mind, give you some of those answers, right? Like those explain. But I go ahead and examine my treatment how to answer, how we answer. Yeah, we just doing the underneath that. Part B. No, never party. Yeah.
How much who's still coming for next time?
How much would you do? It is very to be honest. But what it does do is just break it up.
Yes. That moment.
I did that.
It's in about this.
I think
No, I just have one. Yes, I know starting. I know, I started. I just got rid of it. I don't know, we get something. She said right now. I so red. It was the other. Yes. Yes.
I think a little, and I never see it.
That's something another. Syria is going to be a big selling too, and then and one is going to be yeah. Take that. Hey, Diane, what? No. Yeah.
Alright, let's go.
You're like, hey, you should not see what you should see what on crazy. Yeah, but I mean, it runs too slow. See, I'll be like, you know what? Yes, Yeah, so yes. No. No.
You're done? Huh? Oh, yeah. Where are we going to next after this? Yeah, well, how to get it? We put up speed. That's not what it is. We just make sure speed gets the stuff done because you understand? Well, up there is. Right, before we start, you have to do this. Finish up this. Alright, so we can do module 1, module 2, whatever you want to go over. If not, then we can skip on. One thousand. Oh, it's because that's
Oh. Yes. Yes.
Most cases, yeah. In some cases, yeah. And again, that's.
Yeah, yeah, that's what that's what so we come now. This guy,
Alright, ready? So a source emits a mixture of monochromatic. I just put it here. That's another we have to ask them. But I'm just very No. Every day in solar. How would you try to reach out? Yeah. Alright, let's correct this now. Let's correct this. So a source emits a monochromatic red and a monochromatic yellow. Draw a ray diagram to show the production of the first, of the zero, first, and second. Right. So what they're asking for is the diagram I have in board. Right? That diagram there. So it will look something like this. Right? It has monochromatic red and what's the next color?
Yellow.
Red and yellow. So this has red and yellow in it. Okay? When it goes through, yeah. Huh? No, you just present one way and just say the way has red and yellow in it. Alright? Right, so watch here. Watch here, please. So at n is equal to 0. Will the ray split up? No. So red and 0 is a mixture of red and yellow. What is red and yellow?
Green.
Red and yellow is green. Yeah.
It's orange.
Alright, red and yellow. Right. So n equal to 0 is right. Now listen. Yeah.
Yeah, I know.
Why is it cheaper than?
Because it's also green and orange, so the yellow.
Is answer 20 things? Alright, so yeah, exactly what Matthew said, right? But whenever red and yellow mix, it'll form the color in the middle. Okay?
Red and orange. Wait on.
It'll be redder. What's that? Yeah, kind of. Right? I don't know it for some of them. I don't know it for all. I just know it's not green. I just know like when you mix yellow and blue, you'll get green. Alright. That's a good idea. Right. So right. Right. So at N1 now, we have different wavelengths, right? So at N1, you have to figure out which one will have the bigger angle because they're gonna separate, right? So it will look like this. That's now. You have one here and one underneath. Right? So this is order one. Yeah. Which one on top?
Red.
Right. The larger wavelength on top and the smaller wavelength underneath. Right? You have your red and you have your yellow. That's order one. That's okay? And then at order two, same principle, right?
But the angle we bigger with that, is now so
Yeah,
as the orders get bigger and the orders will start to join.
at some point here. Right, that's order two. Right, ideally to draw this diagram, we should have calculated it, right? So you have to calculate at yellow and red if it actually happening. Okay? But they didn't give you numbers here, so that's why it depicted. Show that red on top and yellow below. Are you okay with that? Do a quick sketch. I want to go to the calculation now.
Yeah. So if you go to the
Yeah, going back. Taking this off, right?
yeah, nice. So
Right.
yeah, it's funny. We get one back, right? Yeah.
Right, next one. Right, they gave you a diffraction grating, second order for red of wavelength and angle. What is the number spacing to grating? And how many lines per millimeter does the grating have? So in part two, they want you to find A. So we do A is n lambda over sine theta. That's okay? Right? N is 2, lambda is 630 by 10 to the minus 9 all over
Yeah.
sine theta. Theta is 43.9. What shall go back for A? What I get for A here?
1.8. Yeah.
1.8.
1.817, like
1.847.
I got 1.7.
If you put in those exact values, what you get?
1.817. I got 1.817, 1.817 by 10 to the negative 6.
Right? Are you okay with that?
I got the system figure out.
1.82, right? Going with that, right? Nice. But that's not the answer, right? Right? Because you still have more to get. I will have to do this. Could I do that there, boy?
And the other time is second line and minus it.
Right. Yeah, what you have to do, right? That's only E.
But and they want to find the space between the lines, that time when two lines are minus us.
No. What's what you're gonna do? Here's what they want. Right? So if you remember, the way we to do it in reverse. Right? A is equal to one line. Right? And one line is equal to 1.82 by 10 to the 6 minus 6 meters. So one line is equal to 1 over 1.82 by 10 to the minus 6. Sorry. 10 to the 6 meters. Does say that? And then if I move this here, it means that 1.82 by 10 to the 6 is equal to number one. I'll look for it as one. Oh, yeah, again. Huh? Oh, yeah,
Why? Remember, he is equal to 1 over 1. Remember, he is equal to 1 over whatever, right?
Because I minus.
What? Oh, yeah.
Right?
Yeah.
So that'll be 1.82 lines. That'll be 1.82 by 10 to the 6 lines in 1 meter. Right? That's what they want, number of lines in a meter. Okay? And then they ask the number of lines in a millimeter. So what to do now?
So you multiply by
Show your multiply or divide. Divide. That'll be 1.82 by 10 to the 3. Right? You divide by 1,000 on both sides.
Good job.
Okay, nice. What's the next part? The next part is find the angular deviation from the normal for the first order red and first order yellow. But I get rid of those two parts. Full the other spam here. Yeah.
Yeah.
Have one?
Lights one.
Finish your two parts left, all right? Which one is it? Krishna? Krishna. Oh.
Are they electronic cigarettes?
I'm just curious, and always just love them thinking that something like what is yeah, but what would you do with one value? Why would you do like every negative? But yeah, but we have realized we have why is this need one? I put this like someone but he is actually seeing this between select. So why do you have what is somebody 1.8? That's one is not yeah. That's it's a very minus. It's a minus. It's a different and you can get it just now. That's not what it's just now. How there? Get 20.3. Just now, we just did. Okay. That's a feeling like that's it. What's that? You good? Oh, will be 1.87 of the 6. So that's hey, so let's try you know, yeah, you so that look right. Yes. And so let's try that. I know it got it to room, right? Yeah. As friends, it's not friends, right? And so that's only trying to get on and keep joking. And now it's not. If I remember correctly, she wanted to hey, right? Yeah, right. He was without pink suit, without big with a big chain and a chain, right?
Yes.
Yeah.
No, I had to like lucky to go out to the tower and see the rest of them and the walkers.
Hey, imagine one drink, yeah, one drink for the car. You come in the car, I drink one drink.
Yeah.
Hey, think in mind, me, I go most of the bottle anyway. We better pack up, right? And speak that, okay? Yeah. We got no one, I want to wait something, right? I mean, drink it since to have the buying. You know, right? When you come off the then go, right? You have the gas station. It is the song. Essence straight in China. We was there when it was the light. We used to something else, but it's dark. Drunk going man. What up? Because normal. Yeah, Marshall is going to. It was Marshall, yeah.
Wash boy, and they start to pull it up.
It is. It's a people that when she
Wood pass, right? Right, I know recording this class again, no?
So, you know you don't want to record the class. After you do so much, no, you don't record the class.
Wait.
So,
I have to
Alright. I'll get through that. So part 3 was what? Part 3, they gave you, they want the angle for, they want the angle for red and they want the angle for yellow. What you all got? What's the angle for red?
20.3. Yeah, 20.9.
And what was the angle for yellow?
Hold on,
Yeah, they want the angle of deviation between two of them, pair the minuses. Where you get for yellow face? 18.4. So the angle of deviation, you have to minus them. 28.3 minus 18.4. This is recorded. I didn't know it was on it live. Right? You can see us, see a mouth and everything.
See that?
Yeah, and I'm training. Yeah. And I'm training this one to pick people and pick how they behave and class and things. No, this one just.
Yeah, I see. That's not very important. It has to start. Right? So what's it about?
Yeah, do what's up after. Delete that privilege. Down privilege.
All your are training the AI to be able to pick all your out.
Wow.
So
When we come in the door, your AI gonna be like this.
So that like trying to stop it on so what's the purpose of that AI camera?
you just to be able to pick out things and pick up patterns and things. So what they will do now, it will send the parents, but class massive vaping and they will do no work and little things that you can pick.
Hey, that's
Alright.
So we got it from that.
Right, that's something I want to clear up.
That is like
Alright, part 4, show that yellow light produces third order spectrum, but red can only produce 2 orders. What are you doing there? Right, so you're finding the max orders for each one. So you're using the formula I wrote it down, right? The max order formula. Remember I wrote it down somewhere for you?
Yeah, no.
Right. So you're finding A and lambda for both of them. And show that you're only getting 3 for the yellow and 2 for the red. Yeah, that's the max order formula, A over lambda. I'll give you a lunch around 12:30, right?
What?
I don't get a lunch around 12:30.
So, but
You can order it to one when it comes.
if I need help, so.
Yeah, very good.
So how long?
Like 5-10 minutes.
What needs?
Yeah.
Like,
All right. So let's go. Cool. You have 1 hand. All right. So what's topic going to do any further?
yeah, it's
Right. Let's stay in module 2 first. So when we're done module 2, we.
So it's really easy.
Before here, anybody here want to do anything in module 2?
Let me see all. Yes, it does.
Yes, and go
Yes, it does. But forget about
So that's formula. Okay, I will do something on that for you. Right? That is things and series and things. Just one little formula. Okay. One more. That will also come in module 3. I think I know where it's at, but I'll show you. Yeah. All right. Module 1. What I want to review in module 1? Right.
You want besides single motion. So no, it's no, the thing when the movement is there.
Man, you do washroom one thing.
Yeah.
You have to have water. Yeah. Follow what we are in right now.
Why actually
What the fluid give each other. I should answer everything to Oliver. Right, and just that circular motion.
Yeah. So
right?
After it was kind of the thing.
Yeah.
Let's charge it.
And you know, I'm looking for a different wallpaper. Yeah. Well, you're slightly big wallpaper like you have in C3. Yeah. I want to get a sticky wallpaper.
Why would that?
Get some white down and take it.
Yeah, the only way to get you have like glossy in.
I didn't know. I had to have gloss on them before. Color and it was gloss. I didn't know.
So maybe
I know I'm looking around behind getting somebody to do it. All right. All right, shut up now. Circular motion. Right? What module 1 topics am I here? Circular motion, gravitation, projectile. Error. Well, right, that's it. That's what we can do anyway. Right, so I will show you the errors and the springs then, right? All right, so let's start. Right, since you want to do circular motion, let's do projectile first. Right. But yeah, no, the equation for motion. Right. So the first thing we're looking at is the equations of motion. Right? In the equations of motion, right, V is equal to U plus AT, V squared is U squared plus 2AS, S is equal to UT plus a half AT squared. Why did I group these together?
Because that's
right. All these have acceleration, and they are used in vertical motion. And then we just simply use V is equal to S over T for everything horizontal. Right? Because acceleration does not affect horizontal. You want to do it? Right? So watch this here. Let's say I gave you an example and I want to show you for projectile motion, all you need to know is this. Right? You don't have to learn all them proofs, you should be able to do it. Right? So watch this here. Let's say we have somebody, let me say there's Darian, he get fed up at school, right? And he wanna jump off. Right? So he going to run horizontally with a speed of 4 meters per second, right? Right? And the height he jumping off is a nice little height at top of the building. Let me say it's about 40 feet, 40 meters, right? Right. We want to figure out number one, right? We want to figure out when he jumps, he'll look like that, right? When he reach here now, we want to figure out how far from the building he is. So we know where to clean up or wash down the thing. And we want to figure out number one, we want to figure out the time he takes to hit here, right? So we know what time not to pass there. And we want to figure out how far from the building he hit, so we know where we are to watch down and thing. All right?
So we can go off with
All right?
Wait,
So what's it?
So 2 people in your class.
Who's that?
I don't know about that.
Yes, I'll go.
It's not much.
Okay, and answer right. Oh no, I log out and the person before was a different class. And I recorded. All right, so good. So how are we going to work this out? Right? How are we going to work out time? So to work out time, we have all these options here. Are you okay with that? So what do we have here? So it's important that in the question you identify what you have. So here you have vertical displacement, right? So this is vertical displacement. This velocity here is the initial horizontal velocity. So if you're moving horizontally, what is vertical velocity? 0. That's okay? Are you okay with that? Right. And so those are the things that we have. We know that gravity is going down, so it's gravity positive, right? And we're using 9.81, right? Yeah. Right. So now, how are we going to get time? We have horizontal velocity, but we do have horizontal displacement, so we can't use this. Right? What about this one here? What about this one here? Right, but if I do the first equation, the problem with the first, I don't have final velocity. I don't have the final velocity, right? So I can't use 1, I can't use 2. I can use 3 because I have the vertical displacement, I have the initial vertical velocity, I want to find time, and I have the acceleration. That's okay? So what I'm trying to show you is that you don't want to go and memorize any formulas besides this. Right? Once you label your things properly, you can do any question. So if I were to work on time now from this question here, if I work out the time, right? I have the horizontal velocity. Why does it have a v here, right? And I could use the initial horizontal velocity. Because horizontal velocity during this journey is the same because it's unaffected by gravity. That's okay? So I could use this same value for the time I worked out here and then solve for S. That'll give me this horizontal. You okay with that? So all that we need to do, proper diagram, proper labeling. Highlight what is vertical, highlight what is horizontal. Okay, and then use the equations of motion. Okay? Right? Huh? Yeah, no, leaving it. So let's take a look at circular motion. So because sometimes you might need these things, I wanted to show you this before I show you circular motion. Right? Circular motion, right? Objects at our level could only move in 2 types of circles. A vertical circle or a horizontal circle. Right? Let's look at the vertical circle because the principle is kind of the same. If I give you an object attached to a string moving in a vertical circle, then we know that the object has a centripetal force acting on it. And the centripetal force is always a resultant of all the forces acting. So for example, here, and besides a resultant, and it acts towards the center. Okay? It acts towards the center all the time, centripetal force. So if I said at that object, on that object there, to all the forces active, you will write weight, you will do tension. That's it. You can't join centripetal force, right? Centripetal force, though, is a resultant of these two acting towards the center. So acting towards the center will be tension minus weight. That's okay? So the resultant of these two acting towards the center is tension in the positive direction, weight in the negative direction. And then if I solve tension, the maximum tension is centripetal force plus weight. Right? So down here, this string will have its maximum tension. Are you okay with that? We have to remember a few things as well. We have linear velocity, angular velocity. Linear velocity is angular velocity by r, and angular velocity is 2 pi by f, by the frequency it movement went. Okay? We need to know about centripetal acceleration. That's omega squared r, or v squared on r, or even omega by v. Have you ever used that? If you know the acceleration, then you can find the force. Okay with that? So just multiply everything by m. M omega squared r, m v squared on r. Okay? So these are the things that you need to know about circular motion. All right? In a horizontal circle, same principle. Centripetal force acts toward the center, weight acting downwards. My question is, what contributes to the centripetal force here? Yeah, tension, right? So what you have to do now is you have to, right, you have to resolve tension. But you can watch it and figure it out.
Yeah.
So here's what? Sine of cos. Right, that's opposite, so that's sine. Okay, cos is here. Everybody okay with that? Right? So nice. So let's try some questions involving these, and then we do gravitation. And I will show you errors, right? Right, so go back, look at some questions. What this game is come on. Yeah, well, find out people. But they have it. Yeah, but you get from this, take a pick and set. Right? Right, start from these. If you get in trouble, there's not the same question, right? If you get in trouble, I'll help.
Just because she was, she got me one.
Yeah, I never seen that.
So yes, and she got me one. Oh, I was asleep. I don't know. Well, she reading the plan sheet.
No, it's only that. I said the question, yes, but. Thank each other. Second view. That's not, that's the end of the, that's not the end of the. I would put it in the.
So that's the. So that's everybody just going over the.
Huh?
Yeah, everybody just go away. Just do it. We even wait. Just.
This is. What? Okay, no, like what? Oh my God, it's okay, chill, chill, chill. Okay, I'll get it.
And you won't go keep up himself.
I still get my this age.
Just when you see you will go keep up himself.
Ready? Jack, you ready? Wait, like that. Such a picture.
Why?
Take up. Shock the way we do it. Ready, question. When it goes back.
We're speaking to us.
Ready, go back.
I'll finish.
Yeah.
It's the activity of the cross max so center.
How I lost the other two. Oh, yeah.
Hey, bring it there, bring it there.
Give him a what? Oh, yeah. I can start it with without us now, right?
Press, but I get it.
Nah. Oh, yeah, yeah. Right, so something pop up where Darian say he don't know what formula to use to be, right? But here's what your rep party,
Okay, I don't understand how to prove that.
right?
I'll be the.
So, no, I just for party will give you a hint. So what you say? What type of energy the what type of energy the gymnast had here? Potential. What type of energy he had here? Kinetic. So therefore, there was a change in potential to kinetic. So you have mgh is a half mv squared, and you'll get the formula. But I was hoping somebody see something there as well. Anybody recognize that you could have used one of these?
Listen,
His initial velocity is what? 0. Start from. If you know his displacement and his gravity is the acceleration, and you can find his speed,
Yeah.
and you'll get the same formula.
Okay.
Pardon me, but it started from rest. Did she moving up there?
When it's in a.
But you see he moving? See he moving?
He went from up here to
Where he started to where he finished.
right, this is the progress. Yeah, but what it should that kinetic energy of a body of mass and moving it as speed is given by a question equal to that
Right.
and p squared.
That's enough to. Right, so you can that formula there for B is the square root of 2G part 1. Then you have part 1 the calculation using B is the square root of 2G. Because there are yeah, B is not on the last page that you know.
But how we are the address to what we do because there is not some but you
this is a number of it's this guy is not even a
they need one pressure real easy. It can't like it's not even to understand. It's just think it's just spoilers and in fact yeah. Great. What? I get well, that's what you're saying. Oh, that's why. The analysis, the elements are is speed, angular velocity is equal to yeah.
I actually asked Emily that I'm thinking that I mean, I still am not saying from that.
Yes, yeah, but yeah, right. Yeah. Wait, I'm not right, yeah.
Oh, wait. Good.
Makes you look at the acceleration. Oh, so it's back at this point, yeah, yeah, right. Last time acceleration, I think. I just find acceleration, figure it out, sign up. When you talk about it, it's not that big. Wait, the last one. Yeah, the last one is the fine test. Why, so, you know, why do you hear that? So I still got exercise and the question. Yeah, because of using this one there. The only time he's in exercise is this one. Yeah. So he's in this one. Yes. So well, of course, it'll be mass because okay, we found velocity, right? Hey, so centrifugal force is equal to n omega, right? The acceleration is equal to b omega. Acceleration is b squared over r, omega squared over r, and b omega, right? We have b already, and we have omega. So what if I find acceleration? Just find you by omega by mass. Yeah, but you see that. You see you try to argue. All you want is
MV square over R. MV square over R.
what you get pay attention to? Which? Yeah, exactly. No, I didn't get that. I don't know. Yeah, 14 by yeah. I used B omega R. No, just no MB omega. MB omega.
Was it mouse that acceleration? Just find acceleration.
I just never write it.
Yeah, 14,000 or something.
Yeah, 14,070.
That's weird. Oh, wait, no, wait.
No, B, the other one, I got 9.81. That's why I get.
Yes.
Okay. Yeah.
That's not them, sir.
What we and guys are like
Wait, not this is
Yeah.
It's just
Yeah.
it's minus because
That's why.
it's minus.
Yeah.
It's not plus.
Wait.
Oh, well, we just I say yes. Yeah, I get
Wait, which one is it?
A massa escrevendo. That's why I use using
Yes.
Yeah, but I got that answer.
right. I got the minus I did 170. And then after you will get okay.
No, wait.
Yeah.
What are we going for?
Like
What's really argument? Yeah, you know very well, man.
And these formulas really is equal the mass.
and once
Square. Or.
No,
We have this.
centripetal force is any force of mass that acceleration. The acceleration will to omega with 10 power and it is use acceleration. That's why
so I feel from what's our answer. So
Nice. What you got you?
yes, so 734.25.
We have been. What's the bargain? Right, so the free body diagram is the same, right? Same diagram, right? Calculate tension in the rope. So we're using this same formula. So we're using tension is equal to centripetal force plus weight. So, and we have the mass of the guy, our gymnast. We have his velocity he moving with. We have the radius of the part, and we have weight m by g.
So, yeah, why do we use omega b?
It don't matter. It don't matter. Right? Right? So it don't matter which one you use. Even if you use this one here, you'll get the same answer. Because we have b and omega. Right? So work it out and what you get. I think the answer was 2300. What's the answer? 2205. Okay. Pick the next one. Let's do one more now. Gravitation to earlier. Huh? Gravitation to the earlier. There you go. There you go again now. See all that sometimes it miss little things because I might just want keywords.
Why does it come? Because of the gravity. 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 Thing is different. I don't know.
Yeah, yeah.
The next question.
Alright, there you go. Correct. So, I mean, law, that one, let's go again. That's gone through gravitation. And then we can someone will treat.
And then we. Yeah, there. I can have it later. But since we yes, yeah, it has to.
Go. Well, I am new guy of this year. I think that's
Not PH, but it's
As you know, I TED talk. From Qualcomm and Bachman. Wait, which question? Everybody else together?
Shucks.
Mine's already so I'm gonna get a few little.
I guess it was I didn't mean it. Well done.
Wait, that's not so.
Yeah, also where's the answer for now come and figure. Oh yeah, work it out. Oh, this is a summary here, right? This summary, assent and improve, right? Yeah. But it still have a little more definition, in it, not pure formula, right? Like all the trying to study you'll see how much you will benefit from it. Study now. Nobody, you know?
I feel like it's a brush my so it's not edited.
That's big for 1,000. Continue now. You want to brush your 1,000 do?
I say I'm like the. Plus.
They have a technical one, and that's, I don't like him, I make him do it too well, but I. Because that's a good thing, though. You get us where you can. I don't know if you get to say that. And I'm probably before, but. That's that correct now?
What's up? The same.
Well.
You know, this I don't have anybody else do it. Isn't because I am the game.
Final way to put it together, right? So the first part here, straight line motion. Then it's that curve, right?
So then you try to find the speed for the velocity for the so they say at the end of the day, so it accelerates from 0 to 150
Right.
at 6
So right, so during this phase here, right? During this phase here, the straight line motion, right? You have initial velocity, you have acceleration and displacement. So if you have U, A, and S, and you can find the velocity you want to enter here with, and you can find V, right? And then
Yes.
switch the question from straight line now to circular. So you see why I join them, put these two together. So now you could use this and find V. And now come here now and start with the circular motion question with that V value. Because you know the linear velocity he enter with. And oh yeah, video class. They remove things. Okay. Right. So now the particle starts to, now the car starts to enter into circular motion. Right? So after you find that velocity using this, now you come here. Okay? And now you have to figure out now based on what you have. What you get. You have mass, you have velocity, you have R. So you can probably even find circular motion one time. Okay.
Yeah.
Yeah, right, that's correct. It's not. They won't be able to come back. Well, that's yeah, that's why you guys are with it. You guys are give the whole thing through. And when you must be, it's right. So let's correct this out. Let's look at gravitation and do a little module 3, it's almost 12, right? Oh yeah, finish off finally. We have 2 minutes.
Yeah, so when the horizontal, when the result on horizontal force, they're going to be sent to a force. Yeah. So really put photo in the 500 influence and the only dimension of the two exactly. Yeah. I like it. Yeah. Yeah. Definitely. Yeah, I know it's Oh, that because around the velocity of the but see, I am underground, right? Yeah, what you want to Oh, weird. There's no end. You really serious?
Wait, I anytime you see us,
Like, what did you do with that? Wait, when you box service? And the war is out of no, what's that you also? And then, yeah, and then I'll be, yeah. No, why we're planting is when it exceeds. Yes, it really takes. But okay, Ryan.
That's good. Next one. All right. Now you correct all that, and let's move on to let's go into some gravitation and then move on to
Yeah,
I'm thinking about the tree. Well, I got lots of notes.
it's the.
Well, if some of them now, some of them want to buy it. Well, it's not that.
How much money are you
More, I still recording that.